Okay, hello everyone. Welcome back to Introduction to Elementary Linear Algebra with me, Gustina Elfianti. In this session, we will study about matrices. So in the previous section, we explore system of linear equations and methods to solve them, such as Gaussian elimination and Gauss-Jordan elimination. These methods rely on systematically transforming equations into a more manageable form using elementary row operations. To further understand this technique and extend their applications, we now shift our focus on matrices. Matrices provide a structured way to represent and manipulate system of equations, making calculation more efficient and systematic. The next section, we will explore the definition of matrices, their properties, and fundamental matrix operations. So let's dive in. So a matrix is a rectangular array of numbers, symbols, or equations arranged in rows and columns. A matrix A of size m by n has m rows and n columns, written as A m by n. And the entry in the ith column and jth column is written as Aij. So we can write A m by n, or we can like by this one, which means that this one is the entry of the A, or we also can just write like this, or in expand way, we can write like this. So A has n column and m row. So a matrix with m rows and n column is called m by n matrix, or we write as m cross n. If number of row equal to number of column, let's say n, then the matrix called a square matrix of order n. A matrix that has only one row, let's say size 1 by n, is called a row matrix. And a matrix that has only one column, let's say size m by 1, is called a column matrix or a column vector. Two matrices A and B are considered if and only if they have the same dimensions, which means that M must be equal to P and N must be equal to Q. And their corresponding entries are equal, meaning Aij must be equal to Bij. For all entries Aij in matrix A and all entries Bij in matrix B. Now we see some example of matrix in managing a store inventory. Consider a store that sells 3 types of products, let's say laptops, tablet, and smartphone, across 4 different branches, let's say branch A, B, C, and D. The number of each product available at each branch can be represented using a matrix, let's say M. Here, row represent different brands, A, B, C, and D. And the column represent different products types, laptops, tablets, and smartphones. So each element of the matrix represents the stock of quantity of a specific product at a specific branch. Now we see example of matrix in student grades. In a university, students take multiple courses, and their grade can be organized into matrix for easy analysis. Suppose for students Alice, Bob, Charlie, and David are taking 3 courses, let's say elementary linear algebra, calculus 2, and elementary statistics. Their grade can be represented as a matrix G, this one. And here, row represent different students. A, Alice, Bob, Charlie, David. And the column represent different subjects, elementary linear algebra, calculus 2, and elementary statistics. So each element in the matrix represents a student's grades in a particular subject. For instance, here is Alice's grade on elementary linear algebra. And this one is Charlie grade on calculus 2. Now we continue to the addition and subtraction of matrices. Matrix addition and subtractions are operations that involve adding or subtracting corresponding elements of 2 matrices. These operations are only possible if both matrices have the same dimensions, means that the same number of rows and columns. Let me give the formal definitions. Let A be M by N matrices, A be M by N matrix, and also B is M by N matrix. Then we can write A plus B like this. So it means that we add A11 with B11, then A12 with B12, and A1n by B1n. Also, we add AM1 with BM1, and we add AMN with BMN. And also, for the subtractions, we do it on the same positions. So we have A minus B is A11 minus B11, and so on, and A1n minus B1n. This one, A1m minus BR1, and so on, AMN minus BMN. For example, let's say we have this matrix A, and this one is matrix B. So A plus B is 1 plus 10 is 11, then 2 plus 11 is 13, 3 plus 12 is 15, and until we do it until 9 plus 18 is 27. And for minus, we do also in the same positions. So we get 1 minus 10 is minus 9, 2 minus 11 is minus 9, and we do it until 9 minus 18, we get minus n. So we get this one is A minus B. Now we continue with multiplication of a matrix by a scalar. Multiplication of matrix by a scalar or a single number means multiplying each element of the matrix by that scalar. This operation scales the value in the matrix while keeping its structure the same. If A is any matrix and K is any scalar, then the product Ka is the matrix obtained by multiplying each entry of the matrix A by K. It's called a scalar multiple of A. So Ka, we can write like this and like this. So we get Ka is Ka11, Ka12, Ka19, 1n, and so on, and until we get KAMN. For example, let's say Ale tracked his weekly study hours for elementary linear algebra and calculus 2. Here is the matrix. In this matrix, row represent different weeks of study and the column represent different subjects. Means that row 1 is study hours in week 1 and row 2 study hours in week 2. Column 1, hours spent on elementary linear algebra, and column 2 means hours spent on calculus 2. If I decide to double his study hours, we multiply the matrix by 2. So we get 2A is 2 times of this matrix. So it means that 2 times 5 and 2 times 7, 2 times 6, and 2 times 8. So we get 2A is 10, the matrix 10, 14, 12, 16. It means that Ale studies 10 hours of elementary algebra in week 1, 14 hours calculus 2 in week 1, 12 hours of elementary linear algebra in week 2, and 16 hours of calculus 2 in week 2. Now we continue to matrix multiplication of matrices. Matrix multiplication is a method of combining two matrices to produce new matrix. Unlike addition and subtraction, matrix multiplication is not element-wise. Instead, it involves taking the dot product of rows from the first matrix with columns of the second matrix. Conditions for multiplication are: two matrices A and B can be multiplied if the number of columns and of A match the number of rows of B. If A of size M by N and B is size of R by N, then the resulting matrix C will have size M by N. In formula, we can write, suppose there are matrices A M by N and B R by N. Then the result of the matrix multiplication AB is a matrix C M by N, where we can write CI. The matrix C is the multiplication of A and B, and the result is this one. So we multiply the each row with the column. So for the first entry of C, we get from A11 times B11, A12 times B21 plus A12 times B21 and blah 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 plus A1R times BR1. And for this entry of C, we get from AM1 times B1N plus blah 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 plus AMR times BRN. Or in general, we can write it like this. For example, suppose 3 students took 2 quizzes and we want to calculate their final score for the quiz. Let A be the metric of quiz score. So we have this A, where each row represents a student and each column represents a quiz. Now let be the weight of quiz. Mean that the first quiz is weighted 40% and the second quiz is weighted 60%. Now we multiply A and B to get C, the final score of quiz. So C is A times B, where we have this one A and this one B, and we get C is equal to 100 multiply 100 times 0.4 plus 85 times 0.6, and we get 91. And for the second row, 70 times 0.4 plus 90 times 0.6, and we get 82. And for the third row, 65 times 0.4 plus 100 times 0.6, and we get 86. So here is the final score of for the quiz of the 3 students. Now for your exercise, please identify a real world problem. Choose a problem from daily life, business, science, education, or technology where matrices can be applied. Examples: tracking expense, analyzing study hours, grading system, business sales, transportation schedule, etc. Then represent the problem using matrices. Construct a matrices that represent key data in your problem. Clearly define what each entry in the matrix represents. Then solve problem using matrix operations. Apply addition, subtraction, scalar multiplication, or matrix multiplication as needed. Show all calculations and steps clearly. Then interpret the results. Explain what the solution means in the context of the real-world problem. Discuss any conclusion or insight gained from the analysis. And for the submission guidelines, for the title, clearly state the problem you are solving. And problem description, explain the real-world context. And for matrix representation, show how you model the data using matrices. And for solution steps, use proper matrix operations and show calculations. And for interpretations, explain the meaning of the result in a real-world context. Please submit the assignment in PDF format, either as a typed document or a scanned copy of neatly handwritten work. Please do your work in a group, like 4 to 5 people in a group. Okay, so thank you. See you in the next section.